Okay, so in this video, I'm going to do questions 12 and 12 and 13 from the packet 2, task 1. So we're looking at the parallel line properties, number 12 and 11. So this actually more has to do, I feel like, with polygon angles than parallel lines, which is why I didn't really do it in class, but it is a good thing to like practice. So it says in the following diagram, A, B, C, D, E, F is a regular hexagon, and use that fact and other facts about angles to determine the measure of as many angles as possible. Okay, so we have this hexagon that's in bold, and we know that these angles in the middle are those central angles. And we know that from task 9 in packet 1 that to find one central angle, we take 360 divided by the number of sides, which is 6 because it's a hexagon, which would give me 60. And so I know all of these angles are 60 degrees. Okay. So then I also know that the distance from E to O and O to D are all going to be equal, as well as all of these other sides of these triangles, they're all going to be equal. It's the same distance from the center to end of the vertices. And therefore I can find like these missing angles in a triangle. So to find like this angle in the triangle, we know that the triangle adds up to 180. We could do 180, like 180 minus that 60, which is equal to 120. And then I could divide that by 2 to get 60 degrees. And so these are 60. You could also tell like, okay, one angle 60, 2 of the sides are equal. So the base angles have to be equal. And this is going to then be an equilateral triangle with all of them 60. Okay, so then from there, we need to find kind of as many angles as we can. So we have, if we kind of look here, we have these 3 angles form this straight angle, EHD. And so they have to add up to 180. So I have 60 plus 60 is 120. 180 minus 120 is 60. So this missing angle is 60. The same thing, this is the exact same thing. Here on this line, this is the exact same thing. Here on this line, that's going to be 60. Here is 60. Here is 60. Okay, it's just the same property as that one. If I use this line here, this is 60. Okay, I have 2 angles in a triangle that are 60. That's 120. 180 minus 120 is 60. So this one, again, all of these are like equilateral triangles. This is 60. This would have to be 60 again because the straight angle is 60. Then we could fill in our vertical angles. Okay, this one and this one are across from each other. They're equal, they're 60. Same with these 2. This one and this one. This one and this one. That one and this one. Okay, I'm just doing all the vertical angles. Okay, and then the missing angle, well, okay, I again have straight angles, 60, and the rest of this and this angle K are straight angles. So this angle would be 180 minus 60, which is 120. And then this angle is 120 because it's vertical. And then pretty much any other line, it's going to be the same thing. So this is 60. The rest of it has to be 120. That's a straight angle. These 2 form a straight angle. So this has to be 120. This has to be 120. So pretty much all the rest of them are going to be 120 because they form that straight angle with the other side. So this is 120. This is 60 because we have the triangle. This is 60. This is 120, 120, 120, 120. Okay, so those are all the angles in this figure. Oh, I missed one. This one in the triangle is 60. So it's easy when it's a hexagon and you have like the equal angles of 60 degrees. Okay, this is one that's very similar, but now we have this figure in the middle, A, B, C, D, E, F, G, H. That is an octagon. Determine the measure. So we kind of start the same way. The central angle is 360 divided by 8, which is 45. So this is 45. This is 45. Okay, all of these are 45. Now this one's a little bit harder because if it's 45, all the angles are not going to be equal. So again, we know that these are all isosceles triangles, that those segments all have to be equal. So to get the other angle in the triangle, the base angle, we would do the 180 minus the 45 that we have, and then we would divide it by 2 because those two base angles are equal. So if I do 180 minus 45, I get 135 divided by 2, I get 67.5. Okay, so these are definitely not as nice. So all of these angles are 67.5, and it gets too crowded, so I'm not going to write them all in, but all of these here are 67.5. And we don't have to find all of them, we just have to figure out these. So let's see, do we know AQB? So A, QB is this middle one, so that's 45 degrees. TFE. Okay, so I need to find that. So I know this is 67.5 and this is 67.5, and we have like this straight angle. So to find angle TFE, I could do 180 minus 67.5 minus 67.5, or minus like 2 times 67.5. Okay, and that gives me 45. Okay, so this angle here is 45, TFE. Okay, EUD, let's see, where is EUD? Okay, so EUD is this one. Okay, so we know that this is 45, we know this is 67.5, and this is 67.5. So again, we have that straight angle. If this is 67.5 and this is 67.5, this is our 45. This would be the same case. This is also 45. And so we have 45, 45. If you do 180 minus that, you would get 90. It also looks like a 90-degree angle, so that makes it easier. So then we have RHS. Okay, so RHS is this angle here. Okay, so again, this outside angle is again 45, because this is 67.5 and that's 67.5, and we have that straight angle. So to find this angle, we could do 180 minus that 45, which gives me 135. So this is 135. Okay, so then we have angle GSK. Okay, so GSK is here. So this is 45. On this side, it's kind of always symmetric. This angle is also going to be 45. So if we have 45, 45, that's 90. 180 minus 90, this is going to be 90. And so therefore, this is also going to be 90. Sorry, this diagram is so hard. It's really hard to like write all these angle measures in. So then we have PZI. Okay, so PZI is here. So again, I have to go with my triangles. So this is the same triangle as this one. So this one is like 45, 45. This is 90. And so this would also be 90. Okay, so then we have RAZ. Okay, so RAZ is this one. Okay, so let's see, what do we know? We know that this triangle is 45, and that's 45. So this one has to be 135, because 180 minus 45 is 135. And then our last one, WCQ. WCQ. So that's here. Okay, so that's made of two angles. So we know this one angle is that 67.5. We know that this angle is 45. And so if we do 45 plus 67.5, we get 112.5. Okay, so this again is more of an extension. You're not really going to be asked questions like this. And if you do have questions, please let me know on it.